introduction about the company and others and the simulation software. Then we can move on to the how to next agenda. So let me start the presentation now. So this is our agenda for today's meeting. I'm going to give a small introduction on the dynamics simulation and what are where they are using in the corporate and academic and how it is they are utilizing the software. And then I will give a demo on the ProSimulator software about both Instructor Station and Operator Station, which are the two features which in which you are going to be working the model. And from that, I'm going to start a simple model, which is a pulverizer fuel system. It will be a simple model. In that, I will explain all the features, and I will go on with the main power plant systems like gas turbine, thermal power plant, coal generation, diesel and nuclear hydro power plant, like that. I can move on. Based on the timeline, we can skip a few steps, or we can reduce the explanation based on that. So let me give a small introduction about my. So if anyone is joining the call, so kindly mute your audio so that I can give my presentation uninterruptedly. If you have
Yes,
any
Vinay sir, I think okay, you have muted yourself. Okay, thank you, sir.
okay, thank you so much for the support. So my as Suresh has said, my company is generating some basic and advanced simulation models of various process industries like power plant models, and as well as based on chemical industries. We are preparing a lot of models like LNG, gas plant, refinery, fertilizers, petrochemicals, like that. We are generating a lot of models based on the customer requirement. So these are key clients in industries like in refining sections. We have given SKC, South Korea to trade and US. We are getting project from our own, and we are some through Yokogawa and Omega Land Simulation. Like the main vendors will be there, and we are getting the project from them, and we are doing many projects from in our own also. So these are some key clients in the industry sections, and some of the basic models like distillation, power plant models, and some other models we have give supplied to various colleges, and in that some many students are able to work it on many models, and they are able to understand the process very efficiently. So in now the southern India, major universities like Annamalai universities and Shastra universities are there, and other colleges like Kongu Engineering College, Adipa Sakti SVC colleges. In North India also we have supplied it, we have some simulation to various parts of India. So what is the difference between the actual simulation training and live classroom? That's the actual. Okay. Well, in the actual classroom, you will be able to teach them on whatever the equations which they are, which the equipment is based on, and how to design them, and how they are working in the plants. You can give a general idea, but in the in plant training also they will able to go and able to see, but what is the advantage of this simulation is that they can able to control them. They can use the models so that it will be ideally to every models will be there. So we can the students will be able to compare both the models, both the studies and their simulation models, and they can understand better on how the actual equations and how the my industries are working based on that. So in the corporate scenario, the simulation is also one of the major tool. In some major countries like Saudi Arabia, or we are taking some countries in Middle East, the government itself have have given mandatory training hours for the operators in chemical plants, so that they have to attend a certain amount of hours in a training simulator. Then only they can be given as an operator in the allotted as an operator in the particular chemical plant. So many chemical plants are having this OTS software with them. That is a operator training software with them, so that they can work and they can learn some of the mistakes by doing mistakes in the software. So here there is no disadvantage of losing any life or any major cost to the company. We can simulate both the live like pump conditions or tip conditions, some of them, so that if the accident occurs means what are the steps they have to take, like that they can get a training in the particular software. So usually in worldwide, the the use of operator training simulators have been increasing throughout the years from 2015, and we are still expecting the market will grow in the next year also. So let me give a small introduction about the ProSimulator first. So it is just like a some models you can give the training in the Aspen Plus, HiSys, Pro to, like in some of the softwares you may know in the colleges. These are like a steady state models on a particular condition. But in our case, it is a dynamic simulator, which means it will change periodic to the time. That's the main advantage of the dynamic simulators. We can check on how it varies from time to time if we change a particular values, input values, and how the output values are changing, and how long it is taking to get to the point where we are fixing that. Like that we can take many learning in that particular software. So that is the advantage of dynamic simulators. So ProSimulator is one of our own software, which is prepared by our CEO and my other team, and it is given to many colleges and of course to the industries also. So it is what are the benefits for academic students means they can get a initial industrial exposure for the students, and due to that they can get a in-depth process understanding, and they can carry out in-house projects based on that, like what are the readings it will take and how the values change in a particular column or particular power plant. Like that they can take it in industries means the actual advantage is that they can improve the plant safety and smooth the startup and shutdown process, because once the operator is trained in this software, kind of dynamic simulation softwares, it will be helpful for them to prepare for the any mistakes which are about to happen, and they can avoid it at many costs, because they will be trained for many hours, and they will know what will happen if something goes wrong. So they are prepared well for that. So it's the main advantage of the dynamic simulation. As you can see, it's a small comparison of dynamic simulation and steady state simulation. We can in a dynamic simulation means it is used for training and study purpose, but the steady state simulation like HiSys or HiSys softwares, they are used for design and validation purpose only, like a particular for a particular value they can take. But the advantages of dynamic simulation, and again when compared to the steady state means they can give the startup and schedule, like how to initiate the particular equipment from zero to particular design load condition, and how to shut down it in a particular process. That is the advantage we can give with the dynamic simulation. Usually the students will get this type of training in the plants after they join, and after certain years as a process engineer, and then only they can get their hands on in the operators. But in this case they can be trained first yourself, and they can directly go to the operators after a particular time. That's the advantage. So initially in the plants, the simulation, the plant will be connected to a DCS operation, and from there the operators will kind of control the whole plant. That's the actual thing. What we are doing is that we are creating a virtual plant similar to a virtual plant, similar to the original, and we are connecting the same to the similar DCS which we have created in this simulation, and in that the operator will be trained. That's the main idea of the project. This is architecture. of the particular simulator. Here from usually the process plan directly go to the control system and it to the operator console. Here we can give the process plan will be converted to a particular model, and the control system is the actual system which the engineer is working on, and which is it is similar to the operator console also from so they can do their dynamic simulation in that. So let me skip for another two. These are the I just want to give some other emulation softwares available. Yokogawa in Yokogawa means Centum DCS is available, and Honeywell has also their own simulations with them. ABB is a separate company, and Emerson has Delta V, and Siemens has PC57 as their DCS operators. So, these are the operators which are usually present in the operator station. From using these softwares, they are actually controlling the whole plant. So similar to that, we can create the our DCS also. So that's about the introduction of the particular section. If anyone has any queries, you can give, say. And am I going too fast, or it is okay? Like the same speed, we can continue. Just I want to.
Yes,
I,
it is okay. It's okay, I think, Haja. But
okay.
while actual software demo, go slowly.
Okay, no problem. No problem on that. Sir. So yeah, everyone, you will be having the simulation software installed in your PC. So first of all, the simulation two icons will be there in your desktop when you install it. Instructor Station and Operator Station. These two icons will be installed in your seen in the desktop of your screen, sir. You have to go to the Instructor Station first. You should not open the Operator Station.
Can you please show Haja from the desktop, your desktop, so they will get the idea. Don't go
Okay,
from here. Go to the desktop. Keep
okay,
the
just
to desktop.
okay. I will move it.
Yes.
Yeah,
Now all the faculties, those who are going to use on the PC, they might see a instructor station option. If anything else is going on your computer or running some other application, please close all those applications and keep your PC screen as a fresh. Only Google Meet should be on your screen or on your phone, and you should able to see a instructor station. So you have to double click on the instructor station. Start, Haja sir.
yeah. If you and I want to include another information. If you are not able to see any insertion or optimization in your desktop, you can directly go to the file path where it is stored, and you can open it. But just let me go
Everyone,
through.
I think everyone is having a instructor operator station on the desktop. If
Okay,
any faculty is having, any professor having a issue with this, they can just interrupt us. Okay, sir. So
okay,
Prayas sir, I think everyone is using that correctly. Can you please give feedback?
Yes, yes. No problem.
Yes, everyone has that, correct?
yeah.
So go to the, yes, sir. Haja sir, please go ahead.
Okay, sir. So the next, first of all, you have to double click the instructor station. Once you open that, you will be able to get this screen. This is the login ID password screen which you will get once you double click the instructor session. The login ID and password will be sim. Both will be capitals. You have to enter. The password, the use login ID can be in small cases also, but the password should be in the uppercase only. So once you have, if you have typed this, then you can click OK. Then you will see the next screen. This is the instructor specification pre-configuration stage of the instructor session. You can just click proceed in that. No need to do anything. Then now you will be able to see what are the models which you have installed in your PC. Okay. So first of all, let me go to the simpler one, so that I can give the explanation to the all. Then I will come back to the gas
Yeah.
turbine operation.
Tell them the
Okay.
model number as well as name and go slowly.
Okay. So the model number is PS 5031 pulverizer fuel system. Model number is PS 5031 pulverizer fuel system. So I have to click that one and press OK. That's enough. Now the model will be loading, and you will be able to see the instructor station. So first of all, let me walk through the each and every features available in the instructor session first. Then we can move on to the operator session. Okay. So first of all, here the operator session icon is there. If you are clicking that one, it will go to the operator session. So let it be there, and then we can come back. The main advantage of the simulation is to pause a particular model at a particular time, so that we can pause and run. It's the actual advantages of the simulation. So this is the run option. Once you are open the model, you can click the run option, so that the model will be running in the background itself. If you want to pause, you can click pause. So that's the idea. Once you started it, you can see the seconds will be going on. The timer will be started, and the timer will be adding on. So in upper to that, you can see five icons, like six icons will be there. It will usually be selected in 1 into R, that is a real time basis. Same 1 second will be calculated in the model also. But if you want to go faster, like speed up the process, means we can give 2R, or five times fast means 5R, or 10 times fast means 10R. The same go applies, but in a reverse condition for the 0.5. In this case, the timer will be somewhat slow. You can check it by comparing these two timers. So 0.5 means it will be reduced to a how it will slow down the process, and again 0.2 it will slow down further more, and 0.1 is just almost at most slower we can go for this particular. So this is the actual advantage. You can use it in the simulation. So this is the timing scale which you want to you can select based on your model need. So once I am selecting each and everything, here you can see in the instructor event block, you may be able to see what are the things I am done. So this is the instructor event block. Whatever things I am in this instructor event block. Okay. And the above to that instructor event log is the alarm log. So the alarm log will consist of whatever alarms which are triggered in the particular model, and they will be charted here. You can see it in the operator station also, but if you want to see, you can see it here also. And below to the instructor events log, you can see the operator event log. So whatever action you are implementing in the operator station will be logged here, same as the instructor station. So let me come back to the top. Near to the pause button, you can see a snapshot option. So the snapshot is nothing but we can take a particular screenshot of the model, and we can save it at a particular time. If you are able, if you are starting at let me say like 4 o'clock, and up to 5 o'clock you are running a model and you have to go, but you have to start from the whatever stage you have to stopped at the previous date, means you can save the particular condition in the snapshot option, and you can retrieve once the next day you can retrieve the same condition and you can use it. In snapshot we have given the two set of screen snapshots. First one is the backtrack option. This will be recorded on a time scale for each minute. The whatever events we are doing, it will be recorded and it will be saved automatically in the backtrack option. But once you close the particular in the instructor station, the backtrack will be automatically deleted. So you may not be able to retrieve that. But if you are working for a long time, you have to go to a particular go back to the particular times. You can use the backtrack option, no problem with that. But the if you want to save the model even, and it should be saved even after closing the instructor session, means you have to save it here, the snapshot option. Once you are doing once you have run the model for a particular time, You can click save.
हेलो हेलो सर,
Yeah.
अभी जो ये सर बता रहे हैं, ये अभी आपको तुरंत कॉपी नहीं करना है, ये जस्ट आपको एक ग्राफिक इंटरफेस बता रहे हैं। आप डायरेक्टली वो
Hello.
जो कर रहे हैं वो कीजिए मत अभी फिलहाल। उन्होंने एक्चुअल जो मॉडल जस्ट ओपन करके बता रहे हैं कि क्या क्या फीचर्स है, जो वर्क करना है वो आपको, वो जब स्टार्ट करेंगे एक्चुअल, वो तब इन्फॉर्म करेंगे कि आपको ये कॉपी ऐसा ऐसा करना है। अभी जस्ट वो फीचर्स बता रहे हैं वो क्या ओपन किया है। सो हाजा सर, just tell, explain them you are doing showing the features now, then
Sir.
you will start the actual model simulation, because they are confused and they are trying everything, backtrack and all those things what you was trying to say. Okay.
Okay. Okay. Okay.
Yeah.
So let me start the model and then I can. Okay. So so let me come back to that. And once I have started, if the once you have started the model here, you can click the operator station icon once, and there will be a select screen, like pop-up screen will be like this. You have to click the CS3000, which is the operator station number, and you have to double click it. Actually, once you double click it, the operator station will be open, and here you can see the blank screen will be there. There are two options to go to the model page. Either you can give the press the F5 icon in your keyboard, or else you can go to the option here, this icon. In that there will be a toolbox. This is a toolbox option. In that you can select the graphics window, the icon which is here. So if I am clicking this one, the automatically the model will be opened.
सो आपको अगर वो मॉडल का स्क्रीन देखना है तो टूल विंडो ऊपर के साइड में है, और शॉर्टकट में F5 भी क्लिक कर सकते हो। विथ F5 आपको ये पल्वराइजर कोल की मॉडल दिख जाएगी ऑपरेटर स्टेशन पे। सो आप देख सकते हो कि इंस्ट्रक्टर स्टेशन से हम अभी ऑपरेटर पे आ गए हैं। इंस्ट्रक्टर स्टेशन बेसिकली उसको, ये मॉडल्स को ओपन, कंट्रोल, क्लोज, शट डाउन करने के लिए एक इंस्ट्रक्टर एज ए इंस्ट्रक्टर एक्ट करता है। And this operator station acts as a models where actual simulation models are visible. So when you click on the operator, there is a
Hello.
toolbox option. Yes,
Hello.
Aja sir, please continue. Aja sir.
Hello.
Hello. Just wait for seconds.
Sorry team, I'm facing some internet issues, and because of that my disk automatically cut off. I'm sorry. So just let me join it here. Are you able to hear me now?
Yes, able to hear you.
Okay. Sorry for that. Yeah, everyone is able to see my screen now.
Yes, your screen is visible. Pulverizer cold firing system. Yes.
Yeah, okay. So let me introduce some features in that. What are the icons here? It is so generally it is the pulverized coal feeder. We are taking the coal from the bunker and it will be given to the pulverizer via a feeder, which is a screw conveyor, and hot air and cold air will be supplied. So it is a general process. Using that, the coal will be transferred to the farmers. It is a general process description. Yeah, we are having a particular detailed description here. You can check it in the help option, where the model number will be shown in the particular as a icon. Once you the above the manual is for the manual for the operator station. What are the features is there, and the The manual for the operator session is the actual manual there. We have to select the number model number here. Then it will be taking you to the manual of the particular model. Here you can able to see what model description and operator conditions and procedures and what are the features are available here. You can see the things here. So let me come back and explain once I'm using it. So usually I want to explain some features of the operator station first. So the what are the icons you can when I'm clicking that, you are able to see the different see the difference between these two. The first one, FI03, is an actual indicator. So the purpose of the particular icon is to show the value, whatever value of the flow, pressure or temperature, whatever is that, and to the particular string. But the second one, FC02, is the actual controller. So you can able to see PB, SP, and MB. So I'll just give an explanation on what are the features is there. PV is the actual process value. Whatever value is present in the particular string, it is measured and it is given to the as a process value is there. The SV is the set value. So whatever value if you are given to the set value, it will be taken as the set value, ideal value for the controller, and the controller will take action based on that. MV is nothing but the valve opening, manipulating variable or valve opening in some cases. The manipulator variable which will be is the signal which is given to the particular valve which is connected here. You can see the PV is measured in the one side, and whichever signal is going to the valve is through the MV. And if you are whatever value we have to give are giving, we have to give it in the SV first. Okay, so this is the actual difference between the controller and indicator. In indicator, we cannot give any values there. The whole purpose is it will show the value whatever is having in the particular string. But in controller we can give the values. Either we can give the set value in the auto mode. Okay, can you get my point? Is any doubts in
Yes,
the,
yes. Let's do some here manipulation and show them slowly. Okay.
okay, okay. So yeah, and I want to add one more point. The controllers
Just you please close those indicator and start from the starting by clicking on a FC02. Just tell them where is a FC02. Then show them we have to click here. So like this you have to go.
okay, okay, okay. So the FC02 is present and above the feeder here. So we have to click it on the FC02. Then the pop-up of the controller will be given. It will also, the description of the controllers will be also displayed on the top. You can see that. So I want to add another point to the controller. The controller has actually three modes which you can change that. One is an auto mode, second one is the manual mode, and third one is the cascade mode. So let me just give the explanation of both threes. We can change them by selecting the AUT. The AUT is here. No, this is the actual description of the automatic controller. So it is in the auto mode. So when I'm clicking that, you can see a pop-up of the with the three icons. The first one with the hand symbol is the actual manual mode. Okay, the this cycle one is the auto mode selection, and the third one is the cascade mode selection. Not every controller will have the cascade connection usually. If they are having the cascade connection, you can see able to see the same icon in the controller. Near the auto AUT sign, you can able to see the same sign here. In that case, you can select the cascade option. In otherwise, you will be able to select either the manual mode or the auto mode. So let me just explain what is the difference between the manual mode and the auto mode. In manual mode, the controller will be control action will be given manually by the operator. So we have to give the value directly to the MV here. The SV or SV option will not be enabled. You cannot change anything in the manual mode. So let me just give an demo for that. I'm clicking the manual mode. It is asking a confirmation message, and I'm accepting it. So now the icon actually when I am selecting that, you can see the model is in hold condition. It is because I didn't select the run option here. When I'm starting, I didn't click the run option. I passed it and I have gone. So when you are
when it shows hold,
uh,
आपको you have to go to the instructor station, and
instructor
then
session.
there is an option of a run button at the top side. So go slowly. Tell them each and every step where you have to go and how.
Okay, I'm sorry for that. And when you are seeing such a message in your operating station, like model is in hold condition, you can just click OK there, and you have to go to the instructor station first. In instructor station, you have to select the run. So when you select the run, the model will be in run condition. So you can also see the model is running option in the status screen. The green signal will be enabled there. So the which impose the model is running. Now I am able to change it to the operating station. So I'm selecting the operating station now, and I'm
Go
going.
to the operator station.
Yeah, I'm selecting the operating station, and the operating station screen will be open again. Now I'm going to show you about the manual mode of the controller again. So I'm clicking the same AUT there, and the pop-up is shown. In that, I'm selecting the
So
hand.
just a second. Basically, what we are doing here, this pulverizer coal firing system is running in the automatic mode. It is in the automatic mode which we have kept. Now we want to do a certain kind of manipulation here. So that's why we have to convert that automatic mode to the manual mode. So once we convert that into a manual mode, we will able to give the values which we required. We can manually change the control the system and change the value according to the manual mode. So that is why we are moving from automatic to the manual. So we have to click on auto mode, click on the auto, sir. Click on AUT mode. AUT we have to click. Just a second, your screen is lagging. Just wait.
Yeah.
Then there is a hand symbol, Congress ka hath. So it's basically a manual mode. So you can click on that hand. Now you can write down a reason if required. Otherwise, you can click on that round symbol, or you can also click enter on your computer. So both the things you can do anything you can do. So instead of giving reason XYZ, anything you can give ABC XYZ, or even if you click, you can click that blank also and click on now round button. It is the OK button basically, and then say click on that round button. Aja sir, yeah.
Yeah.
So
Now I
now
can.
you can see that auto mode has been converted into manual mode. So now we are now in the manual mode. Now the RPM you can see 980. The coal bunker feeder is running at the 980 rounds per minute. So that is the speed of that RPM. Now we are going to do some manipulation and going to change that RPM using a manual mode. So what are the changes we are going to do, sir? Please do that.
Okay. So when the controller is in manual mode, we can the operator can be we can change the value in the MV section. Okay. If it is in the manual mode, we can select in the MV. We can select that one, and we can give a particular percentage value manually, whatever value we can give. So now I am going to give 40 percentage,
So
and I am
right now 50% is open. It is running at the 50% speed feeder. Now we will
the
make it to the 40%.
Yeah. Now, as you can see, the RPM is at 980 RPM. When I am giving 40, and once you enter that, you can click enter. Okay. In
Enter.
the when I enter it, automatically it will change, and accordingly the speed will also change. Now, first of all, it is in the 980, and now it is given to 784. So you can see the speed change in the feeder section, and
Feeder.
whenever the speed is changed, we can also see the change in the flow also. I mean, next dynamic solution. What happens where the controller is, I am changing the controller. I have reduced the RPM here. So next what will happen, the dynamic simulation will happen. As you can see that the temperature in outside the pulverizer will start to change when I have changed that one. And total number, now I'm going to change again. What are the factors I will be changed? Just I'm going to walk you through the things. So first of all, the temperature is there, the tons per hour. Whatever coal is going outside, the tons per hour or everything. Okay, we can I will just display it with the controller only, so that you can able to see the whole screen. So now you can check now. The speed is at 784 rpm. 32 tons per hour feed is going to the pulverizer. 92 tons per hour of the feed, the pulverized coal is going to the furnace. As you can see that one. So now I am going to change that. I'm going to increase the 40 to 60 percentage. Let's say 60. So I'm going to give 60, and I'm entering the value. So what are the changes came? Now the RPM is changed to 1176.
Just
And
a
as
second.
yeah,
Slowly, because
yeah,
the screen was lagging.
okay,
Yeah,
okay, okay.
okay.
Now
So you
as you
have to
can see,
go in the manipulating value, make it a 60 and press enter. So because of that, you can see there is a change in the coal flow from the feeder,
feeder
as
and
well as the overall output of the pulverizer. So pulverizer has an output of a coal, as well as that the backside you can see hot air and cold air is coming, which is also a good amount of air. So combined mixture of a pulverizer, there is a coal as well as a hot air and cold air mixture which is going there. So that mixture as well as coal mixture, it is getting affected at the end. So similarly, because of that, the coal percentage has been decreased. So the temperature of the, when previously we had done decrease in the percentage of the coal, because of that temperature was rising. Why? Because coal percentage was lower and hot air percentage which was coming from the background was increased. So that's why temperature was rising. Now the, you can see now we have increased the coal percentage, but hot air percentage is the similar one. So temperature is reducing. So that is the effect, that is the dynamic effect automatically takes place in the model. So this is a small model we are showing. So for example, if even if we go to the classroom and we want to show them what is the pulverizer system basically. So this is how the diagram we can show. We can show them some changes. So coal bunker will be there, the feeder. This is how the circuit runs, and it goes to the furnace. So small models has also been included before going to the actual power plant. We will see the actual power plant also, but before that we can explain them the small models. So you can see similarly we seen the some simulation changes in the model. Yeah, Aja sir, continue.
yeah. So when we are going to see the whole power plant model, we will be able to see a lot of features in that. So I want to just give an introduction on what are the features available in the particular screen, the simple model. Then it will be easy for you to understand in the larger model like power plants. So as you can see now, when I'm changing that, the whole thing is changed. So this is the actual dynamic simulation which you can see. I can also change the flow of the hot air using this feed controller, or the flow of this particular cold air using the temperature controller also. Different types of controllers are there, but each and every controller will be connected to a particular valve only. So using that, we can manipulate the whole system. So whatever the icons which are having the controllers means, they will have these symbols in them, like the M or A. Since we have changed the particular FC02 controller to manual mode, it is changed into M. We can show another controller FC01, which is the flow controller of the hot air section. Here you can see I didn't change anything in there. So you can see the control is in auto mode, and the values will be the set value. I have given the set value as 50, and MV as manipulating maybe as 50%. So now I'm going to give another simulation of another change in the particular controller. Since it is in the auto controller, I can change the particular controller in auto mode also, but I have to give the value in the set value section, not in the MV, but in the SV section. Okay, if the controller is in auto mode, you have to you can change the value in the set value section. Based on that, the MV will automatically change and the process will be adapted based on that. Okay, so I am clicking on the SV here. Now you can able to see SVs are given us 50 tons per hour. The hot air flow is actually given us 50 tons per hour. So let let us say I'm going to increase the flow to 60 percentage. I mean 60 tons per hour. Okay. So I'm giving enter the value of 60 and I'm doing enter. Now you can see the control is taking action automatically. So based on the set value, the controller is taking the action. The MV is increasing accordingly, and you can see the process values are also increasing. And including that, you can you can see the changes in the flow temperature of the particular stream and also temperature to the outside of the pulverizer also. So the whole plant will be adapted accordingly. Whatever condition which I give you, the changes in the whole plant we can see accordingly. We have to understand the process if you are going to if you want to know whether in where the actual changes occurs when you are changing a particular values, you have to understand the process description first. Since I want to show the features of that, I'm showing the features first, then we can get back to the next thing. Okay, so in the auto mode I have changed the SP value. Now the MV is increasing and you can see the value is nearing the PV is getting nearer to the set value. Okay, so this is the actual part which I want to explain to you. So if the one thing is that the control in controller, the icons will have the C as in their name usually, and they have the icon at the top corner. You can see either M or A based on the controller type. And if the control that's a controller, okay, the using that you can manipulate the whole plant. So once I'm in the controller means three modes are there: manual, auto, and cascade mode is there. In cascade mode is what I can give the explanation later, but just I want to wind up the session for particular this one. So the manual mode is here. So if the particular if you are changing the controller to a manual mode means the value can be entered in only in MV section only. Okay. If the controller is in auto mode, you can change the value in SV section. You cannot change in the MV. In the auto mode controller, you cannot change the value in the MV section. Even though I am selecting that, the pop-up screen will not come. The same goes for in manual mode also. If I am selecting is in SV mode, SV section, the value will not, the pop-up screen will not come. In the manual mode, we want to change, you can select it in the MV section. In auto mode, you have to give it to the SV section. Okay, everybody get cleared in that one. So
yes, now
yeah.
I think it's okay.
Okay.
And sir, किसी को भी कुछ भी doubt रहा, directly you can unmute your mic and just ask. If it is glowing slow, fast, how's the speed, pace, then whether you are understanding or not, any question, any doubt, sir, directly आप पूछना. Instead of मुझे कॉल करने की भी जरूरत नहीं है, डायरेक्टली इस मीटिंग में ही अभी इंटरप्ट किया तो भी चलेगा सर. ठीक है
सर एक क्वेश्चन था मेरा.
बोलिए.
सर कोई सिंबल रिप्रेजेंटेशन है? मान लीजिए कोई हमारी डिवाइस है, अगर वो 1000 आरपीएम पे हमारा सेफर ऑपरेशन हो रहा है, लेकिन हम उसकी आरपीएम अगर इंप्रूव करते चले जा रहे हैं, मान लीजिए उसका हमने 1000 से ऊपर कर दिया, तो कोई रेड सिग्नल है या कुछ ऐसा है कि ये शो करेगा कि ये मतलब सेफर जोन में नहीं है, कुछ ऐसा सिंबल?
हाँ सर, वो आप एक्चुअल पावर प्लांट जब आएगा ना, ये भी स्मॉल मॉडल से इनमें वो सारी सेटिंग्स नहीं, जब होल पूरा प्लांट का मॉडल आएगा ना, वो जो आपको आवाज सुनाई दे रहा था ना सिग्नल का,
ओके
वो वैसे टाइप का आवाज उसमें भी सुनाई देगा. वो सिंबल भी यहाँ पे, ये जो स्क्रीन होती है यहाँ पे देखिए, अलार्म जो सिंबल है उसके नीचे की जो लेयर है, वो जो टैग, वहां पे सब दिखाई देगा आपको कि कौन कौन से एरर्स है या कोई प्रॉब्लम्स है।
ओके, और सर ये शेयरिंग नोटिफिकेशन है, इसको बंद कर दीजिएगा, हाइड कर दीजिएगा।
शेयरिंग
ये
Yeah, okay,
नोटिफिकेशन,
okay, okay.
बस बस, ओके, थैंक यू।
Okay, thank
ओके
you.
ओके प्लीज गो।
Okay. So, uh,
Now Haja sir, you please show them the trends also, the live trends which were generating.
yeah, okay. I'm going more.
Yeah,
So,
please move.
yeah. So the controller, we can see the trend section also, which means whatever changes we have given that we can see that. So in the controller, particular controller, I am selecting. I have to go to. I have to right click in the mouse. Okay, not left click. You have to right click it, and you can see tuning, trend, or group. Three options will be there, and I am selecting a particular controller using the right click option, button of the mouse. You can see three options will be popped up, like tuning, trend, and group. So first of all, let me give, goes to the go by order of it, right? So tuning section means if I click in that, you will be able to see the controller specifications. What are the specification of the particular controller? You can see in that. So everyone will be able to see the screen. No, there is no lag. So is there? So let me just go give the explanation of this particular tuning. So the controller is specification is FC02. It is a speed controller, and as you can see, what mode it is there, manual mode or auto mode. What mode is there? You can see it in that, and high value of the particular one and low value, and process SH means it's a particular high value. SL means low value. PV is process value, SV is set value, what value which in the SV section. MV is manipulating variable, and you can see the alarms values also. HH means high alarm. Or alarm once if the value crosses 100,800 means alarm will be popped up, and you can hear the alarm in your particular system. Usually, if you are using the model means try to reduce the volume in the system so that once if your alarm is triggered, you can get it. It can get noisy in that. Okay, and similar to that, the low alarms will be also there. Low alarm, low alarm, high alarms will be there, and what are the values are given there. And for if it is a controller means controller, it has a PID value for the taking action in that. So what is the P value of this particular controller, I value of the controller, D value of the controller, you can see it in there. And this is the tuning of the particular controller. Now, if I want to go back to the particular model sections, I can press F5 on the keyboard, or you can select it on the toolbars also. Now I am going to the model page. So if I am selecting F5, I can see the model page again. Okay. So moving on to the next one, the trend option. So trend is nothing but based on the time how the values is changed, like that we can see if the values is increasing or decreasing. If it is in the straight line means it is steady for a particular time, like that we can see it in that. Since it is a long one, I am going to reduce the area of the particular one. Now time I am selecting. There are some options is there in the top of that. You can see the graph selection.
Excuse me, sorry.
Yeah.
Please repeat after F5 what we can do.
Okay. I'm going back to the model page now.
Okay.
So first option we have we can see that we have seen the tuning option. Now it is a trend one. Trend is nothing but we can see the graph of the particular controller, how it is, whether it is changing period of time according to the time, or it is settled in a particular value. Usually in plant, particular chemical plants or power plant plants, they will monitor the trend line also. If there is a minor changes in that, you can see the graph going up and low in the particular in the graph. So in that case, they can see there's something wrong in there, and the operator will take action accordingly. So that's the use of the particular trend option. So now I'm going to you see the trend of the FC02 controller. Okay. So now I'm selecting, right clicking the option, controller, and I'm going to select the trend. Once I select it, then you can see the trend option here. Okay. Now here it is grouped, like for the red color line is for the FC01 controller, and green color is for the FC02 controller, and yellow line is for the TC01 controller. Okay, since there are only 3 controllers in the model, you can see it in the operator station. The line trend lines are mapped for the 3 controllers of this particular one. Now the graph is move, as you can see, the graph will move on as the time progress. The graph will move on with that. So now I want to see the whole graph, means I can shorten the time. So like there's an option in that above the graph. You can see time reduced option is there. Everyone is able to see now. So now I am going to select it there. Then once I am selecting, you can see the changes in the time interval below in the graph. Now I'm going to click it on the again. Now we can see again the time reduced for again also for some more. Now you can see the changes in the FC02. Whatever we have changed some values in there. No, first we have reduced the FC02 MB. Then we have increased that one. So based on that, the trend line also changes. The green line will be for steady for some time, and after some time it is get reduced because we changed the value, and then it is settled for a particular time. Then again we have changed the value. Now the graph is going up, and then it is settling at the particular point. You can see the whole thing in the particular graph itself. This same goes for the FC02 and TC01 controller also. Okay, everybody understood that one? Shall I move on to the next option?
Yes, of course.
Yeah, thank you. So now I'm going back to the model page. So I'm pressing F5 again. So once I press F5, I'm back for to the model page. Now I'm going to select for the third one. I'm right clicking the controller. You can see group option. Okay. So this is nothing but the group of the particular controllers which are displayed in the whole plant. Now you are seeing in the small model. So in case of a power plant, there will be a lot of controllers. We cannot. We have. If you want to monitor a lot, many controllers at the same time, we have to group it accordingly. The groupings will be allotted based on first itself, based on the client request only. So I'm going to the group page now. I'm selecting the group. Once I selected that, you can see the whole controller section is there. The FC01 controller, FC02 controller, and TC01 controller. From here also I can manipulate the whole model, but I will not be able to see the changes in that. Changes in the model page, but I can see the change, control the options here itself. Okay. This is the actual purpose of the grouping option. Everybody understood? Can I move on to the next one? Okay, I'm moving on to the model page again. I'm pressing F5. Now I'm getting back to the model page again. So this is the options which are given to the controllers. We can you can see the tuning of the particular controller. We can change it there also. If you want, you can change there also. And I'm able to see the trend line. What are the changes I have done, and how it is settled in that, and how the actions are taken on for the other controllers. I can see it in the trend option. The third one is the grouping, and it is easy to control the whole plant in the particular control section itself. So that's the use of the group section. Okay. So as you can see, there is a small FOD icon on the top corner of your pages. Everyone is able to see that icon. So just let me explain what is that FOD page. Okay. If I am clicking on the FOD means, just I will show you. When I click on the FOD, you can see the similar screen here. similar screen to the DC model page. You can see the whole screen there. Now some other options are here. So the purpose of using this FOD page is that usually in any plan, if you are taking consider any plan, means not all the valves or all the switches or all controllers will be all the things will be controlled from the DCS on DCS itself. Some we have to call the operators, we usually called the field operators, which are present in the plant, and they have to switch it on and ensure the particular valves are opened or not. So for that, we have given a separate pages like a FOD page. FOD is nothing but field operating devices. That's a short form of full form of FOD. Field operating devices. It is we have given it as a separate pages as a to give a advantage. Advantage to the students how the actual DCS kind of works on plant. The DCS screen will be separate, and some controllers you have to go to the plant and they have to control there only. So if to know that about that, we have created a separate page as FOD. Okay, that's the purpose of FOD. We can just for switching on particular equipments and changing the valve position, we have to come here and manually we have to give open. So here I want to add another information to you. Now you can see a particular valve in the seal air section, the blue color line. Seal air section, you have see the HC01 valve. HC01 is nothing but the hand controller valve. Which these type of valves, hand control valves, will not be connected to the DCS. The field operators will directly go and open or close based on the DCS operator's request. So when we want to change that value, is we can directly give the value to the MB option. Now I am going to click on the HG01. Okay, I'm clicking it on. You can see a pop-up screen of HC01 and what is the description of that, and you can see the this one is in the manual mode. Everyone, can you see that one? You cannot change the controller to auto or some cascade here. The valve will be in only in manual mode. You can change the value directly in the MV option. You can the same as in the controller. I have to click it, then the data will be there. I have to give a particular data value, like let's say 80, and I am giving enter. Then automatically the value will be changed. Okay, so this is the difference between the FOD and the DCS page. DCS is the actual model page. You can see the now the top right corner, the this then FOD is actually changed to DCS, and I'm clicking in that on the DCS pages. You can see our actual model pages there. Okay, so these are the basic features which are available in the operating system. Some other features is also there, like alarms, signals, and other things. Now it is not enabled in that. I will explain it on the next models. Okay. Now I'm going back to the instructor screen and to give on some other information. So I'm going to the instructor station. In that, I am passing the model. Okay, for particular time I'm passing the model. Like I want to explain some features in that. So in instructor station, in the top left corner, you can see the mode options there. When I click that one, some my selections will be there, like opening a model, startup mode. Startup mode, in that it has two state, design and cold state. Design state is that is the actual one which we are running, like a steady state model at the design value. Full load condition, the model is running. Every valves are open and every pumps are operated, and the flow is going on steadily. There is no change in that. So that's the actual design state. The cold state is nothing but the whole plant. If the whole plant is shut down, every valve will be closed. The pumps will be switched off. So like starting a new plan. So that in that state, when everything is shut off, that state is known as cold state. Okay, so let me just give, if I'm selecting the cold state means, do you want to change the startup condition option, will be pop-up icon will be enabled, and you have to click yes. Once I'm sorry, if you are clicking that, the alarms will automatically go on. So I want to explain that one, so I only enable that. Kindly reduce the speaker volume if you are having any trouble. Okay, so now the cold state is operated. Now you can change, you can see the status of that in the Instructor Station. Left side, startup condition is cold. So I have selected the cold state condition. It is mentioned there. So now I am selecting the run option. Now I am going back to the operator session. Okay, which is already open. So I am going back to the operator session. Now you can see every valve is closed. The you can and the pulverizer is switched off, and the feeder is also switched off. I can go and see the FOD screen. Anyone is able to see the screen now. Now I'm going to the FOD. Okay, FOD screen. Here you can see every switch is off, and the valves also switched off. Okay, so this is the actual cold start. Nothing is switched on. Everything is shut down. From there, we can start up and go to the design state. By manually we can give the values. We have to follow the procedure in the startup, given in the startup procedure in the manual. Okay, there's a in manual, if you are seeing, there will be a startup procedure. Just here startup procedure is there. You can follow these procedures, and you can operate it on the operator station, and you can get back to the design state by manually. I will show you, but just I want to give an introduction on that. Okay, so now I am going back to the operator screen, operator station. Here model means you can able to see the alarms at the top left corner. There will be a blinking here. So this is the actual alarm screen. Once I am clicking that, what are the alarms present here, and what alarm is triggered actually. So everything will be enabled. So as you can see, some icons will be in green and some icons will be in red. The green depicts that they are okay, and the red color or depicting is that they are particularly low or particularly high. The low alarm or low alarm will be indicated here. So everything we can see there from here. Okay, this is the alarm option which is present in the operator screen. Now I'm going back to the model page of the operating station. I'm pressing F5 now. Now I'm getting back to that operating station. Okay, so again I'm going back to the instructor station. Okay, now everyone got the idea about the cold start. Okay, I'm clicking. I have clicked on the instructor station. Now I want to explain some features. We can see it in the next model maybe. Okay, no problem. I'm going to open another model to explain further features on that. Okay, so I'm clicking on click on the mode, and you have to click open. In that, I have to select another model. So let us say next one, oil firing system, PS5032 oil firing system. Now I have to click yes. Now what will happen means the operator session will be closed automatically, and the instructor will open the another one model. Now we can change. You can see there's a change in the model ID PS5032, and the model is oil firing system. Now usually when the model is opened, the startup condition will be automatically enabled at design state only. So this design state is present here. Now I'm going. We have to open the operator session again for the next week. I'm selecting the operator session on the top left, and I'm selecting CS3000. Double clicking it. Now the operator session is again open. So say I am pressing F5 now. So this is a different screen, different model. So different pages will be there. So now this model is oil firing system. Usually, what the how the oil is circulated to the funnels of the power plant. That's the actual separated model for that. And how the automation system is there. This is the actual model. Okay. Now you can see. Now I'm going to the alarm values. As you can see, there will not be any alarm because the model is in the steady state. So the values are not in the low value or high value. All values are within range. So there will not be any alarms. Okay. Now I am going back to the operator screen.
So by using shortcut F5, you can come to the operator screen, or using a tool button graphic window. Just show them again.
Yeah, tool button. Yeah, the tool button is present near the navigation window button. This tool button, and here graphic window option is there. You can select it when you are in the another screen, like alarm or trend or grouping. Any option you have selected this, you can see it. You can come back to this using this option or pressing F5. This is the shortcut key. Okay. Now I want to. You can see some other options like I'm going back to the instructor session. Okay. You can see other options like I'm going to select in the mode, and you can see below the startup mode there is a real time scaling. That's the real time into time scale, which we can select in the here dialog box itself. There is a you can select in the mode option also. Next one is the history, which is nothing but whatever snapshot we have taken there we can use. Now I will show you how the snapshot is stored and how we can retrieve it. I want to give the explanation to the sorry. I want to give the explanation in the malfunction and performance evaluation. Okay, this is where we can trigger some malfunctions to the model manually, so that and we can see the changes in the model first. Okay, so I'm selecting the malfunction and performance evaluation in the mode. So I'm selecting that. Once it is selected, there will be a pop-up screen. So based on the models, the triggering will be different. The first one is failure. Like equipment failures is if there's you want to depict means there's some options will be included. Next one is the disturbances. So I think I have opened the wrong model to explain that one. To explain these conditions, some values will be there. So I now it is not included in this model because it is very small one. So shall I start with the gas turbine if it is okay with everyone? Because we want to, the time is going and we want to give other
Yes,
options.
yes, you can move to the actual power plant model.
Okay.
Anyone that having any doubt till now?
Yeah.
No.
Okay, please go.
Okay, I'm moving on to the power plant model. So like same, I'm selecting the mode option. I'm selecting the open. Okay. In that, I'm going to select the gas turbine operation. PS 2018 gas turbine operation. Okay. I'm selecting that and clicking OK.
हाँ यार तुम एकदम भोज खाने आए हो.
So now the model is open now. The model is to the PS2018 gas turbine operation model, and now I'm going to open the operator session. Okay, I'm clicking on the operator session icon in the instructor session and double clicking the CS3000. Now you can see the blank screen. Now I am going to use the shortcut key by pressing F5 in the keyboard, and you can see the index page of the model. So since it is a larger one, like comparatively to the other models which I have seen before, so it has some features accordingly. So here the index screen is there. Now either I can go on to any pages by selecting these icons, or I can use page down option in your keyboard. There will be a page down option in your keyboard. I am selecting the page down now. Okay. So first of all, if I click the page now the next page will be automatically open. You can also navigate using the icons which are shown in that. Once you open, when you open a particular section means there will be navigation buttons on the top. You can use that one and you can move accordingly, or you can select the buttons on the top to go to the particular pages. Okay. So let me just explain what are the pages is there. So first page is the air system. So it comprises of the compressor and dampener valve to the compressor, and how the supply air will be configured in the particular first page. Now I'm moving to the second one. Now I am selecting the button on the top of the operator station, combustion. So here the actual depiction is how the fuel is supplied to the furnace. So the air system is simpler depiction of the air system is also here shown here at the bottom of this model page, and you can see the fuel oil supply and fuel gas supply, which is combined and given to the gas furnace and air supply is given to that. So the once the oil and fuels are burned, the flue gases generated. This flue gases going to the next section, the turbine. So I'm going to select the turbine or generation option. Here you can see the generator here. That the oil and gas will be mixed in the F001. This is a furnace, and the flue gas will be going to the generator here. So turbine here. So the turbine will the lube oil to the turbine will be supplied at the bottom. That there's a lube oil tank, and then from using the pump, they are pumped to the particular turbine via a particular heat exchanger to cool down the oil temperature. And you can see the turbine is connected to a generator, and there's an exciter switch, and the generator is particular how much watt is generated. Like that we can see the values in the whole screen. At the top left corner you can see the power of the generator, reactive power, system voltage, generator voltage, generator current, power factor of the particular generator, and the frequency. And you can see the at the top right side of the screen near the GT001, which is the turbine, you can see how much speed the turbine is running. You can see 3000 rpm, and what is the efficiency, like speed efficiency, you can see it in the below that, and how much vibration is making. And the bottom right corner you can see how much heat rate is actually supplied to the fuel and how much fuel is consumed for a particular hour, and overall plant efficiency also you can evaluate it in here. So this is the depiction of the gas turbine operation. So air and fuel is burned in the furnace, and using the flue gas, the generator, the turbine is rotated. Based on that, the generator is generating the power. You can everybody know the operation. So let me just move on to the features which you can see it in here again. Okay, now I'm going back to the instructor session. Okay, I'm clicking on the instructor session. I am now I am going to run the model for some time. Okay, let it run. Now the model has started to running. I am going. I want to give explanation on other features like malfunctions, which I have in the previous model I am not able to show, I can select my mode, and there's a malfunction performance evaluation icon is there. You can select it either here or in the instructor station screen itself. You can see the like a warning symbol there. In that there is a malfunction icon is there. You can click there also. By two method you can open the malfunction screen. I'm selecting here now. When I am selected, you can see failures. In 4 sections will be there. Now it is in failure section. What are the equipment failure which can we can impose it to the model? Okay, these are the equipment failures. First option: fuel oil pump trip. Uh, uh, Everyone knows about what is strip and what are the interlocks means, or I have do I have to explain that one? Anybody having doubts on what is strip and interlocks means? I just want to confirm because if I'm moving on to the next point, it will be if someone don't know means it will be confused for them. I just want to know if anyone don't know that I can just explain in a simple way. So I assume everyone knows that. So let me move on with that pump tip. So fuel oil pumping pump. I'm going to trip the fuel oil pump. So let me first locate it in the operator screen so that I can show you how easily. So I'm going to the going back to the operator section. I'm moving back to the combustion bay because where there is only the fuel oil pump. So fuel oil pump is here. Fuel oil section is coming there, and the pump number is P001 or P002. So I have to trip now the P001 pump is running actually. If I trip that, it will stop. So I'm going to trip that one. Now I'm going back to the instructor station now. So fuel oil pump trip is there. I am clicking on that, double clicking on that. You can see the delay second. You can see the option now.
Go slowly. Your screen is lagging. Okay. Go
Okay.
slowly. Yeah.
Okay. Are you able to see the fuel oil pump trip delay in seconds or pop-up screen, everyone?
I hope everyone can see. If anyone has issue, please inform so we can also repeat the step again. I
Okay.
hope everything is fine.
Okay.
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 Yeah.
I'm just repeating the previous step. I'm selecting the fuel oil pump trip. I'm double clicking it. Okay. I'm double clicking it. Well, then you can see the pop-up screen, and if I can give the value on how much after how much seconds the pump trip should be enabled. So let's say 10 seconds. Okay, 10 seconds. I'm selecting it and I click OK. Once I click that, after 10 seconds it will switch on. So I'm going back to the operator screen. Now you can see the pump is actually running. I'm not seeing using. Once the pump is stripped, you can see that automatically the values, the pump is switch off, and there is no flow here. The flow will be reduced, and the temperature of the furnace outlet also you can see the temperature is decreasing since the trip is enabled. So now trying to switch it on. Okay, I'm selecting the SW001, which is the switch for the pump. And I'm selecting that, and there's an option is there. So I'm double clicking it. Okay, in the start option, I have to double click. I'm double clicking it. There is no action is taken because the pump is actually tripped. So we cannot do anything in that one. So I'm going to disable the pump trip option. I'm going back and switching off again. When I come back here, I have to double click it again, and I double click it. I have to give the delay in seconds. Let's say 5 seconds. I have delay. I'm giving the enter value as 5. Clicking OK. The delay timer will be running, and accordingly the status will be, the pump trip will be off. Now I'm going back. The pump will be switched off only. I have to manually on it again. So I'm clicking on the switch of the pump here, and I am double clicking the start. Now you can see the pump is switched on and the flow is generated again, and the temperature started to rise again. So likewise, we can generate other failure conditions for the rotating equipments. Usually the equipment failures will be enabled for the every rotating equipments, including compressors also. So now I am going back to the instructor session. So as you can see, other failure conditions available to this models are compressor failure, bleed off valve fail open, this condition. Bleed off valve 1 and 2 are nothing but, just let me go back to the operator station and show it to you. In operator station, there is a air system here, and clicking the air system button, you can see the from the air compressor there will be a bleed off line separately, and usually it will be closed. We can manipulate this from the instructor session by switching it on from there itself. So once it is triggered, the flow will be reduced to the combustion chamber. The air will be supplied to other areas, like that happening. So that's the actual purpose. Now I'm going back to the instructor session, and the final one is in the equipment failure is the lube oil pump trip. Okay, and similar to the failure equipment, we can also disturb the operation. Near the failure icon, there will be disturb option is there. I'm clicking it. Once I click that, you can see 3 different conditions where we can manipulate it. Okay, so first one, what we have seen is the failure option. Now this is one is the disturbances. Okay, here what are the boundary condition we can change, like fuel gas pressure, which is usual. Now the value is in 3.5 kilogram per centimeter cube. I can delay it. I can change the value to another value, like and compound inlet air pressure, and molecular weight of air, heating value of the flue gas. Everything I can change. Each current for each operation there will be what are the values currently it is given. It is shown. It will be shown in the current value. We can change it. So for example, let me change the heating value of the flue gas. Inlet air pressure of the air. Okay, inlet air pressure. I am selecting it. Second option, I am selecting it. Now you can see the difference from the failure one. There will be a value and how much seconds it should be delayed, and what is the ramp function, but whether it has to increase or from that, like that we can select. So and you can see the minimum and maximum value allotted for this particular component. We can enter any values within this particular range. So now since it is at 0.98, let me give value of 1.5. Okay, and I am delaying it to 10 seconds. Once I clicked OK, the disturbance will be enabled after 10 seconds. So once I am clicking OK, I will be moving back to the operator session to show you the actual value there. So I am clicking OK now. I am moving back to the operator session. This supply air pressure will be at near 0.98 and near to 1. Okay. Once I am changing that, the flow will be automatically changed. You can see FIC001, the value is changing accordingly because the pressure is changed, and the flow will be altered accordingly. So since now since the controller is in auto mode, it will take action accordingly and get back to the set value of the particular set value. Okay, so now it will take action. Now we can change. So now we are giving some disturbances and other malfunctions that we are triggering. We can log. We can use this to the academic purpose. Like we can logging the values. What are the values we have changed, it is changing, we can select either 2 or 3 values, and how the value affects the how the value of one variable affects another variable. We can take the data from there. So how to do that? Let me explain that one. Okay. Now for that, I am going back to the instructor session again. I am changing the compressor in the tab pressure, which is okay, no. Now I am changing it back to the previous value, 0.98, and I am giving it 2 seconds delay is enough. Just I am clicking OK. Just I am reset it to the previous value, and I will show you how to map these values. You can there is a procedure which you can use it to use it for a lab procedure and map the values. So let me just go close this one and show you. So we have seen some options in the mode. For these options are in the advanced training option. Near to the mode, there will be our advanced training is there. So I'm clicking on that advanced training. First one is the tag summary. So what are the indicators, controllers, and whatever tags are present in the model, there will be a summary here. And what is the deviation for that particular will be shown there. I'm clicking on the tag summary first to show you about that. You can see the list of every tags and what are the description and the unit and their present process value and what is the design value actually in the design state and how much it is deviated. Like that you can see, yeah, for each and every indicator and controller you can see it here. Okay. So next one, I'm going to the summary report. The whole report will be generated based on that. This PV logging is the actual one which we can use it to log the values, change the values and use it for the lab purposes. Now I'm how to use that one. I'm going to show you. Now I'm going to select the PV logging. Once I selected the PV logging, you can see there will be a pop-up screen with the PV logging type, and the first option will be select PV logging configuration file. Since there is nothing configured here, we have to configure new file itself. You can you can select it based on your purpose. So for the demo, I'm going with an idea. Okay. So for first, you have to click the configure tag list file. I'm selecting it, and first of all, you have to give a title name to that. So let me say reading one. Okay, reading one. I'm taking giving us a title. You should not use any space or underscore option to this particular naming. You should the naming title of the particular configuration file should be only with letters and numbers. There should not be any space. Okay, please note it down. Then there will be an error for that. So I'm giving the option as reading one, and I'm adding the file. Okay, I am clicking to add. So once it is added, you can see the file name will be logged as reading1.ps2018, which is the model number, and it will be logged there. So here many controller names and indicator names will be there. You may not know which controllers we have to select it. No problem in that. You can go back to the operating session and you can choose the number and you can change it like accordingly. Now I'm going back to the operating session. Okay, so usually the amount of fuel supplied and how much power is generated based on that, or how much heat is generated, we can log it again. It will be useful for that reading students. Okay, so let me check with the next combustion page. I'm clicking on the combustion page. So what is the title of the fuel amount which is going to the furnace? I have to know the indicator number ID. So I'm going since it is showing down, I'm clicking here and you can see the title of the indicator. So the fuel oil which is going to the fuel supply which is given to the furnace is F5004. Okay, I have we have to select that one. So now I am going back to the instructor session. F5004. I have to select it, and I have to click this option. yeah, I have to give this transfer to the selected tags option. I'm transferring. Now this option is there. So next variable what we can choose. We have to choose the generator, how much power is generated. So I'm going back to the operator session now. Now I'm closing the indicator. I'm going to the turbine option. Here the power is generated in megawatt, like 71.5. So I'm clicking there, and you can see the indicator ID for the power generator. So EI001. Okay. So now I'm going back to the instructor station. So I have to select EI001. So I have to search the EI001 is here. So I'm selecting it, and I have to transfer it to the selected tags. Okay. So for demo purpose, I'm selecting the how much amount of fuel is coming and how much power is generated. So I'm selected the option. Now once I have selected that, I have to click save. Then I have to click OK. Okay. Just for a precaution purpose, please click save and then OK. Then once I click OK, the readings will be configured. Now I am closing this one, and in the previous screen, the select PV login configuration file. When you select the down arrow, the whatever file name we have configured there, it will be shown. So I am selecting the reading one. So frequency, how much in what frequency the logging should occur. That's the actual thing. So I'm let us say like 5 seconds. Okay. So I'm logging each value for 5 seconds in time. Once I'm selected 5, I'm switching it on. Okay, that's the only thing I'm going to do. I am switching it on. Once I switched on, the values will be logged in the background in the background purpose. Okay, let it be there. We can let us go and change the fuel value for, like, reduce it for to something, so that we can change. We can see the reading change in that. Okay, I'm going to the see operating session again. I am going back to the combustion page. In that, now the fuel oil is pumped to the tank, and it is pumped to the particular valve. The particular valve is at 3.5 kilopascal pressure. So I have to reduce the flow. So let us say I have to reduce the flow, means I have to close the valve, like that only. No. So I am going to select the PIC 002, the controller I am selected. I want to close the valve. Since it is in auto mode, I can change the pressure value to a lower value, or I can change the controller to manual mode, and then I can close the valve using by reducing the M. So now I am choosing the lateral one by changing the controller to manual mode. I am clicking it on the AUT symbol. The pop-up screen will occur, and now I'm selecting the hand symbol, which is the icon for manual mode. I'm selecting that. I'm selecting confirm. Now I can change the valve position, close the valve, like that. So I'm clicking on the MV of the controller. Now it is at 50% opening. Is the valve is open at 50%. That MV is there. So let us say I have 35%. Let us say. Now I have reducing the opening to 35%, and I am clicking enter. Once it is entered, the value will be changed, and accordingly the pressure, the flow value will change. The pressure may remain constant based on the pump, but the flow value changes accordingly. So let it run for a particular time, then we can see the reading in the background. So now I am going back to the instructor session. Now you can see the file is actually logging continuously for some time. We can use this. We can see the file now. So now if I want to see the file, just let me pause the model to view the file. Okay. Now I'm going to pause the model. Now I'm going to pause the reading also. When I off the reading, close the logging, the file name will be generated in the report. If you want to see, you can click the open file option there. You have to click that one. Once you click that, you can see the file. So at the particular time, the fuel value is 14.97 and the amount of power generated is 72.62. And for next 5 seconds, what is the value? Next 5 seconds, what is the value? Like that, it has logged on to particular values or whatever time you have run. So the readings you have logged on in there, and it has been saved. We can use we can note down the readings here also. We can also generate a particular graph based on the logged readings. Okay, there's an option for that also. So let me show that one next. I'm closing the reading now. So the readings will be logged on the file as reading 1 file. Okay, so I have to note down that one. I am closing that. In the same advanced training, down to the PV login, there will be a PV trend option. There will be 3 options will be there. Historical trend. Historical trend is used for whatever file we have logged there. We can use that logged file and you create a trend separately. Real-time trend means while the model is running, the graph will be automatically generated in the screen itself, just like in the trend section, which you are seeing in the controller. And XY trend is we have to select particular 2 controllers. Accordingly, the values will be generated on the screen. So let me show first what about the historical trend. Okay, I am selecting the historical trend option. Once I have selected the historical trend, whatever readings logged file is there, it will be show the file will be automatically selected there. I'm selecting the reading 1 and I'm clicking the open option. Okay. Once I selected, there is a PV trend view software will be open, and we have to select the axis, whether what are the axis, based on the axis we have to check it. So now I am going to select the axis, like let's say fuel versus load. Okay, so I am selecting the x-axis as a tag mode. So in x-axis, either time will be there or tags. I'm selecting the tag option first. Then this icon will be enabled. I will click down. You have to select the x-axis. I'm selecting the fuel option. So F. And y-axis should be the load. So EI001. So x-axis will be FI004 reading, which is the fuel reading, and y-axis will be the power generated reading. So once I have selected the x-axis and y-axis, I have to read the values now. So I have to select read tags option. I am clicking on the read tags. Once I clicked on that, you can see the fuel change, and accordingly every the power generator values also change. You can see the values accordingly. Okay, the values will be logged here. Now I want to create a chart for that. Now I have to select draw chart option. Then I have to pick. There will pop up a confirmation screen will be there. I will select yes now. Okay. Once I selected, automatically the Excel file will be open, and you can see the values there. I'm maximum the Excel icon now. You can see the graph here. So the graph will be automatically generated whatever axis you are selecting. Now these are the logged values. Fi will be the fuel values. Whatever fuel values we have changed, now the value is reduced. At least they have reduced.
So I hope everyone got the procedure to plot the graph. इस किसी को डाउट है, कोई क्वेश्चंस किसी का नहीं हुआ प्लॉट या फिर से रिपीट करे, एनीथिंग, एनी क्वेश्चंस? यू कैन आस्क डायरेक्टली. ओके, आई थिंक सबको ग्राफ मिल गया होगा कि एक्स एक्सिस पे आई थिंक फ्यूल कंजप्शन है, वाई एक्सिस पे द वो भी जो लोड पे इफेक्ट है. यस, एंड जनरली अभी ये जो रीडिंग्स ली है, these readings has been taken on very small interval of time. मतलब how many seconds you took, Haja?
5 seconds, sir.
5 seconds. 5 seconds is a Like for example, what happened? बहुत छोटा timing है. We can increase the timing and which tag we had changed, what value we had changed here.
We have
Where
fuel value, fuel valve we have closed. We have changed the
fuel.
fuel valve. Yeah, we have
So can
closed
you
the
please
fuel
show me the
valve.
fuel valve? Fuel
Yeah,
valve. Where is
yeah.
that?
I'm going to the operator station now.
Mhm.
We have to see the screen. Like once we understand the process, it will be easy to know the valve.
Yeah,
The
this
fuel oil
screen.
line is here. When this
Yeah.
valve is coming, I have selected the pressure controller here. That's a valve which is manipulating the flow also. So I have
Okay, so
selected
you have
the,
manipulated this value.
yeah, this value. I have changed it to manual mode. It is at first it is in the 50.6 percentage of MV is there. I have changed it to 95%. Like that means
95%.
I have closed it.
Okay, the default value was what
50
previously?
50 percentage 50 percentage.
50%.
I have
Now,
changed that.
go to the graph. I just want to make one point here. Please go to the graph. Yeah,
Graphics accessory. Okay.
Excel sheet. Yes. Now you can see this graph is very much erratic. So we cannot draw some kind of conclusion here. So the reason being, we have taken the readings at a very short interval of time, 5 seconds. It's very short because any dynamic changes happens, the effect of that takes the time required to take that effect from start to end in the whole plant is a bit higher. So 5 seconds is very short a time. So what we can do, actual practice wise, we can, instead of moving from manual value 50% to 35, we should go slowly 50 to 45. Then we have to also increase the reading step of, instead of 5 seconds, you can say 20 seconds or 30 seconds. Then we can move from once we come to 50 to 45, again do some small change, come to the 40, and then again one more change, waiting for 30 seconds, then again make one more change which is again 35, then again wait for 30 seconds. So we can increase the size of the trends which we required. The timing we can increase, the recording timing in the PV log screen can increase, and as well as the changes manipulation we do in the plant, that can also be changed step by step, so we get a good amount of readings with a proper graph. So that is how we have to proceed. Now generally what happen, whenever we take any thermal practical, we measure some value. Somewhere we measure a pressure, somewhere we measure a temperature. Okay, so various values we measure. So we take the readings on the certain interval of time. For example, any heat transfer we go, or thermodynamics we go, or power plant engineering we go, any thermal practical we go. So for we are taking a reading, we take a readings, 4 to 5 readings at a different intervals, do the calculation, plot the graphs, and get the conclusion. So this is how generally we follow. So same thing we have followed right now. Whatever the thing which we have followed, it is the same thing. We have done some changes and we are plotting the graph. The same thing which we generally do in the practicals in the lab. So same thing we have done here. So we have to be bit carefully, slowly we have to reduce the values and increase the time span of the recording the reading, because here only 5 seconds was taken. Instead of that, larger time like 30 seconds we have to take, and we have to wait till the all the calculation goes. So 2-3 minutes you have to run the whole model and then stop the recording. So this is how we have to proceed further. And you can do follow these type of steps to the all the models. So various आपको जो भी मॉडल है जिसमें जो भी रिकॉर्डिंग करना है, ये प्रोसीजर सेम है. आपको बस टैग्स आपको जो चाहिए वो ऐड करने हैं, और उसमें एडिटिंग वगैरह जो भी करना है वो आपके हिसाब से, कौन सा टैग चाहिए, कौन सी वैल्यू चाहिए, कौन सा ग्राफ चाहिए, डिपेंडिंग ऑन दैट यू गेट ऑल द थिंग्स. ओके, प्लीज गो अहेड.
Okay, thank you, sir. Thank you for the explanation. And as I said, we can see increase the time span, and we can get a lot more progressive graph, clear graph to for the children. I have used a particular change, like just one change in the fuel value. You can change it on any other things like air supply. Also, we can change the value, and then we can see the changes in that. Based on your procedures, you can select the indicators, and you can log that based on that. Okay, then the process much more expandable. Whatever option you are choosing, you can do that. So now I am that's the explanation for the historical trend. So let me move on to the real trend option. In real trend, I'm going to the advanced training now. I'm selecting the PV trend, and in that there's a real trend option. Okay, real time trend. Here you have to configure what are the values. The real time trend graph is there. Now since we have not selected anything, we have to configure that first. So I'm selecting first. There's a setting option is there. I'm going to select that one. So what's the indicator we have to select? Like that, we have to select it here again. So in that first of all, we have selected the we can select any controllers and like EI002 and a FI003 like that option, and I am clicking OK, and you can see the graph is there. Now here the graph will be seen only for to the uh, according to the time interval. You can see that one. Okay.
Yes.
Yeah. So that's all about the options here. And again, XY trend is similar to that of option here. You can click that one. You can see X Y axis. You have to select particular indicator now.
Sorry, screen is lagging. Yeah.
Okay, sorry. Once you click the XY graph in the advanced training, there will be a pop-up screen like that. You have to select that one. Whatever option is what are the axis you want to choose, you have to select. So similarly, I'm selecting FI03, EA01 again. Now I'm going to give the export to sorry models in fast mode. So I'm selecting the run option now. So once the model is running, the values will be automatically logged here, and we can see the values here in the export. Sorry, there is some issue with my net connection. Let me show you again. I'm running the model now. So I'm going to the advanced training, PV trend, XY trend option is there. I'm selecting the particular value, and you can move on to the next one. Okay, same way only. So yeah, and next to that, I want to just show you about the snapshot option, which we logged, which are not shown in the previous one. I'm selecting the snapshot option now in the operating station, Instructor Station. I'm selecting the snapshot. You can see what are the since we have run the model for some time. I'm going to the have some backtrack here, and now I have to save the particular condition. Whatever values I have changed, I have to store it for some time. Means for I am going to snapshot option. I'm selecting save first. Okay, save. You can give any file name accordingly. Here there is no you can use space also. There is no restriction here. I'm taking test one. I'm selecting OK. Then now the condition will be saved. So if you want to open this particular condition again, once I open the model, usually it will be open in design state only. Now I have to come back here in the snapshot option. I have to come back here. In the snapshot, I have to select the test one, and I have to click restore. Once I click the restore, there will be a pop-up option like here. Okay. Then I have to click yes. If I click yes, means now you can see the status. The startup condition is the SLP test one. That means the snapshot is loaded again. Okay. Let me move on to the next model. Is a thermal power plant model. Then I will show actual generated snapshot is there. I have saved a particular condition file. I will show you how.
Yes, please move to the thermal power plant model.
Okay. Now I'm closing the. I'm selecting the open file model.
Yes. Now we will move to the thermal the gas turbine model we have finished just now. Move to the thermal power plant.
Okay. In thermal power plant, I'm selecting PS5015 thermal power plant. clear selecting that. I'm selecting OK. Yes. So the model is now opened. I'm going to show the model page now. So I'm selecting the operating station, double clicking on the CS3000, and I'm using now. I'm going to select in the toolbox option now for your understanding. Tool button in that graphic view, the graphics window. Once I selected that, there's a index screen will be there. Since it is a large one, similarly the for fourth screen is screen. First, let us see the overview first. In this overview, you can see the whole power plant models. What are the values there and how it is actually working. You can see the whole power plant model. Here it is the furnace. The steam drum is there, and this is a stack to chimney, and below that is the deaerator and low pressure heater, high pressure heater options to the condenser systems. And you can see the generator and high power turbines, high pressure turbines there. And at the right side you can see the utility section. It's a high pressure header and low pressure header, medium pressure headers are there. Okay, let me move on to the next screen. There's a arrow button is there. I can use that one, or you can use the page now. I'm selecting the navigation button now. Here you can see the only the boiler section. So you can see the boiler section is there. Fan section, ID fan, induced draft fan, forced draft fan, FD fan is there, and various controllers, fuel gas line, boiler drum. The lines and input line to the boiler drum is from the by LC03, which is at the rightmost corner, and you can see from HP heater the actual line is coming up. And if you want to know any description of the particular models, you can go to the help option. There will be a manual SP title with the model number. You have to select that one. Then the model description will be open. In that model description, sorry, you can see the whole description, and PNID diagrams will be there, startup procedures will be there, and description of the process will be there. So I'm selecting the description, and you can see the whole description of boiler section and particular steam drum and economizer. The students can go through that and understand the whole process using it in a detailed way. They can go through it, and or you can explain it in a simple form also. They can the whole description will be there. And as you, let me go to the next section in here. And the graphics window options are there here. What are the graphics screen? There, the graphics screenshot is attached to the manual. And these are the normal operating conditions. Means the controller, what are the design set values of the design values which are shown here are the set values of the particular controller. And the indicator, what is the value it should be shown, it is showing in the design state. So everything is logged here. And below this, you can see the startup procedure, how to start the entire power plant model is there. Okay, so let me go back to the operating station. Okay, and this is the boiler screen which you are seeing now, and I'm selecting the next one. This is the condensate where the actual water supply is started and supplied to the boiler drum. The water from the water tank, it will go to the condenser tank. From there, it is pumped to the deaerator through low pressure heaters, and from the deaerator, it is going to the high pressure heater, and it straightly goes to the economizer. That is the boiler drum to there. The depiction of the drum level will be also depicted here, LC03. You can see the same controller in both pages. The LC03 will be also in the condensate system, and you can see, go back and you can see the LC03 is in the boiler section also. For controlling purposes only, it is shown in both screen. Okay, so next to the condensate system, the utility section is present. Where the steam from the boiler is utilized in various sections of the plant, and it is passed back to the condenser. Like your flash tank is there. From the flash tank, it is going back to the condenser. Okay, so let me just show you how to start up the whole plant. So for start up the whole plant, we have to select the cold start of the particular model. So for that, I have come back to the instructor station. I have selected mode. In the startup mode, I am going to select the cold state. In that cold state, there will be a pop-up screen to change whether we want to change the startup condition. I am selecting yes. So once I am selected that one, the model will be in the background. I have to run the model before doing any changes in the operator session. So I am selecting the run option there. Now I am going back to the operator session. Now you can see everything. The alarms will be going on because there will be no value. There will be low alarms popping up on every sections. So you can see the what are the alarms which are popped up. You can the top left blinking option. You can see many alarms are being popped up. We have to close it by controlling the model only. So I'm going back to the model page by pressing F5. Okay, you can see the model is now in the full shutdown state. There is no liquid in any tank level. Now I have to fill up every tank, and I have to fill the boiler drum to the start. So to understand how to start the procedure, I have to go back to the manual to read it to understand how to start. Okay, so let me walk through a few steps, and I will go. I will show you the snapshot which I have saved previously. The model number is 5015. So I'm going back to the PDF. In that starter procedure, we have to the first five procedure options are usually done by the operators in the power plant. So for the information, we have included that first of five options, like maintenance is completed and the healthiness of DCS and everything, and instrument as and compressor are working fine. We have to check that first before switching before controlling anything. Because if the signal does not go correctly, the plant will not work actually. So you have to check the first five options first, then we can do. Since it is a simulation point of view, everything will be automatically selected only. We can move on to the next section. So next will be the condensate water system. So initially we have to fill the condenser tank, and then we have to move on to that. So let me walk you through the procedure, and for some time I will go do it. Okay. So let me, first option is that open the makeup valve SW14 from the DM plant to condensate storage tank to fill up to 4000 ml. Okay. The lever should be filled to the 4000. Now I am going back to the operator session. In condensate system, we have to change. So I am selecting the condensate system. So the SW14 is the actual number which is given there. So I'm selecting the SW14, which is the switch of the valve. So I'm clicking open. I have double click it now. Once I click that, you can see the level started to rise here in the CST tag. The level will rise accordingly. Like it started to increase since the open the internet line. So I have to fill this up to 4000 mm. The value of PV should nearer to 4000 mm. So it will take time because the tank capacity is much high. So it will take time once if you are doing a startup option. So similarly, once the 4000 mm is there, then we have to move on to the next option. Okay, I will show you. I will just walk you through the next options. Now I have to select the air ejector switch and create vacuum inside the condenser. So once it is started to fill in the tank, I have to switch it on the air ejector SW17, which is given in the manual itself. I'm I'm going to switch on the starter. Once I switch it on, and you can see the condenser pressure dropping continuously. It will drop and it will go back to minus 90 kilopascal. Okay. because we are creating a pressure difference way so that the fuel can the flow of the water can be carried out from one tank to another without any pump. So using the ejector, we are creating a negative pressure there. So the once it reaches 40, we can open 4000 mm. We can open this L00 LC01. That's a level control valve of the particular tank. For opening that, how I'll be show you how to do that. I'm clicking on the LC01. MV you have to increase that. If I increase the MV, the valve will actually open. So for just an example, I'm going to change it. Usually I have to wait for some level to build up. So if for walking you through the step, I'm just opening that one. I'm going the value as 10%. Okay. MV I am giving as 10%. I'm clicking enter now. The value will be changed to 10. Now you can see the flow will started to rise. Below the wall there will be a flow rating 3.91 tons per hour flow is coming here, and the level of the drum is started to increase like 0.017 mm. It started increasing. So likewise you have to fill up this drum. Now this I am have to once the condenser level is, we have to open to 50%. We can cite once it is given. Once the CST tank is 4000 mm, we can directly open the LC01 valve to 50%, and we have to fill the condenser tank up to 900 mm. Once we are it is reached 900 mm, we have to follow the next procedure. That which is I'm showing. We have to both the suction and discharge valve of the pumps. So before starting a particular pump, we have to check the switch it on, open the suction and discharge valves of the pump. So I have to switch on the SW01 and SW03, and after that either one pump, either MS01 or MS02. Since there are two pumps, I can select either one, and I can switch it on the pump, and then I have to open the PC01 valve. So let me show you in the operator screen now. Now the SW01 and 02 switches are the suction and discharge valves of the particular pump. So I'm opening that one. So I'm selecting the both switches and double clicking the open option on both one. So once they are open, now the pump is ready to switch it on. So once it is filled up, then you have to switch on the pump. But when you try to switch it on now, it will not switch on because the level is very much low. So since the level is very much low, we cannot switch on the pump. We have to build up the level. The pump, the particular level should be maintained so that the pump can be operated. These conditions are known as trip conditions, which are logged in the back of, at the end of the screen. You can go by next like navigation button, next option. I am clicking next again. It's a planned overview is there. So once the plant utility is there, in the plan, once you are going to the plant utility section, if you want to know what other trip condition is there, it is mentioned in the manual at the bottom. You can see it there also, or you can use it. You can see it in the model page also. I am using the page down option in the keyboard. Sorry, it is not enabled now. Let me walk you through that in the manual. Okay. So the trip condition is actually enabled for that purpose. So once the level is built up in the condenser section, it should be particular level should be there built up. For then that only we can switch on the pump. So we have to wait for some time to the level to build up for to the fast startup function. So I have saved a particular snapshot function of the filled up level of both condenser and the deaerator. Once the condenser tank is opened now we can open the PC01 valve, which is mentioned in the procedure, and we can give the supply the line of water to the deaerator. It will pass to the low pressure heater and goes to the deaerator section. From that, the level of the deaerator will start to rise. We have to fill that level up to a particular point. Then we can switch on the boiler BFA pump, which is nothing but boiler feed water pump. and we can supply that to we can supply the water to the boiler pump. So I have loaded the snapshot of this particular model. Let me open that and show you how the snapshot is opening. So for that I am going back to the Instructor Station now. Now I am passing the program. Since I have saved the snapshot, I'm going to click on the snapshot icon there, and I'm going to click on the snapshot. Here you can see through file types. PS5015 is the steady state of the actual model, and I'm going to select the tank filled up, which is the condition which I have saved after working on that for some time. I have saved the condition. I'm clicking it that, and I'm clicking restore. Okay. Once I click restore, there will be a pop-up. I have to select yes. Now I can go and see in the operating session. Now, as you can see, now the level has been filled up for the level dehydrator at up to 1000 mm, and level of the condenser is at 680 here at 3000 mm. The tank has been filled up, and it has to run for some time. Then you can combine it, line up to the boiler. Now I am going to, since the model is in past condition, I am going to run the model first. I'm going back to the Instructor Station and running the model. And coming back to the operating session. Now you can see the changes in the level of the both condenser section of inlet of the condenser tank and the level of the reactor tank. It is changing continuously. Now I have to walk you through. You have to follow the same procedures which is given in the manual. You have to move on to the next one. Right. So according to the procedure, let me just show you. Once I have to maintain the circulation in that, and I have to come. Now I have to switch it on the PC01 to auto mode with the set point of 20 kilogram per centimeter pressure. So let me show you that change. I'm going back to operator station. Now PC01 is in manual mode. I didn't change that. I always show you that one. So since it is in manual mode, now I'm going to change it into auto mode first. I'm going to change it to the auto mode. Okay. Now I'm going to change the set value to 20 kilogram per centimeter square. Okay, I'm going to change it to 20. The valve will automatically change. Controller will take action accordingly, and will set at the particular pressure. Once the pressure is higher, you can see there will be the level increasing in the dehydrator tank will be high, whereas the level started to decreases in the condenser tank. And let me walk you through the next one. Now I have to open the valve of the particular dehydrator pump, and I have to let it fill 2000 mm, which I have already done there already. So I'm going there. Then I have to line up the BF, the boiler feed pump, and I have to check the level should be at the above 1000 level. 1000 mm should be there, which is already there. 1200 is there, so it is enough. So the next procedure is to line up the particular pumps to the particular for the boiler feed system, which I have already done that. I have switched on the suction and discharge valves of the particular pump, and I have also opened the recirculation line to the tank for meaning some pressure to the pump. I have also opened the next valve, which is on the line to the boiler drum. Then I have to check for the level control valve, which is also I have opened for 10% open. So every valves are, the lineup is clear. Every valves are open, and the level the tank of the tank level is also above the desired range. So I'm going to start the pump now. Once I have started that, you can see the level, the pressure started to increasing in the tank, and the level in the particular drum will be decreasing particularly. We have to maintain a particular amount of pressure here, so I am opening some more weight, like 15%.
Go slowly, go slowly. Okay.
Okay.
Whenever you click on before going there, please say I'm opening this. My cursor is here. Like
Okay.
that, we will follow that.
Okay.
Because we
Sorry.
click at the faster mode and directly we give the indicator, but we don't understand hear you okay.
Okay, okay. Sorry for that. I will just show you. I have in the previous step I have selected the PC01, which is the lineup wall of the boiler feed water pump. I have selected that one. I have increased the first. It is initially in 10%. I have increased it to some 15% so that the pressure will also increased it, and now the tank will has to start to fill up. So since there is not much of the flow to there, so I have to increase some more here. Let us wait for some time, because once I have given some action there, it is the manual model is running. It take some time to take action. So I have to wait for some time to check it. Since I have opened this wall, I am going to open the valve of the level controller also to inlet the line. So I'm going to increase it to let's say 15%. Okay, let's say 15%. I'm increasing. Now you can see some decreasing in the level, which I can see in the previous screen, the boiler section. So I'm going back to the boiler section now. You can see the tank started to fill up, and the levels are coming now. So now I'm going back to the procedures to see what I have to do now. Now I have to fill the level to 0 mm. So usually the boiler level will be shown as plus and minus readings. Minus 400 mm to plus 400 mm is the reading of the particular boiler term. I have to maintain at 0 mm. So let us so since it is increasing for some time, I have to increase furthermore. Like I'm going to open the LC03 valve furthermore, like 20%, let's say 20%. I'm going to increase it, and I have to wait for it to reach the 0 mm portion. So I have to wait for some time to reach that one. So similarly, you have to move on to the accordingly. So, it is a huge plan, so it will take some time to get to the design state. Okay, so let us see for some time. Okay, so now it is started to increase again because of the pressure drop again at the back. You can see it in the next screen. Condenser system, there will be pressure drop once the model is open. So I'm going to open again in the PC02 for some more to increase the pressure. I'm increasing 15 to 20%. Now you can see the increasing in the pressure, and as well as the flow will also get increased. So since there are two walls in the lineup, we have to manipulate both the walls to get our level in that. You can monitor the level from the screen itself. It is not a problem here, because the level control valve is here. I can select it there, and I can use it. You can use it like this, or you can also change it into auto mode, and where the controller will automatically take action. But usually, while working on a model, it is advisable to work on a manual mode to understand the process much more. Why? If you know the process, it's not you want to start up first means you can directly change the controller valve LC03 to auto mode. I can give the set value as near to zero. Near to zero, like minus 10 or plus 10 value, I can select it, and I can give set value, or either I can give zero also, whatever, based on the procedure. Once you started to work it in the model for some time, you know what are the problems you are facing in there. So I'm going to now I'm for your preference, I'm just going to change it to auto mode, and I'm going to select the level as minus 20 for my purpose. Just let it fill to minus 20 first, then we can see that. Since the pressure is dropping there, there will be not much of a flow there. So I have to increase the flow in the PC02 valve also. So I'm increasing it to 30%. Not much of a build up there. So I'm going to increase it to 40% now again. Now the pressure increases there. Now the level is coming to drop to the reset point. Okay, now I'm going back to the manual mode to control it to reduce it to 20%. Now we can see the level is filled up above the 0 level. I can pass the model here. I can hold the model here. I'm going back to the condensate system. Boil model now it is above the zero. So yeah, we can move on to the this above zero. So I have to drain it for some time. So So like I'm going since the drain valve is there, I'm giving the MV value in the HC03. I have selected the HC03 valve. So I'm to open the drain valve to reduce the somewhat level here. I'm giving 10%. You can see some direction is there. So once it is getting near to some value near our to set point, you can just close it and we can wait for the level to fill up the tank. Now I'm going to see the next procedure there. Once it is filled up to near to 11, maintain the drum level 0 and close the FRS 30% valve. FRS valve is nothing here but the feed regulation station, which is normally closed here. For the simulation purpose, we have normally closed there. For the operation purpose, we have included that point. Okay. So I'm going back to see the next point. Open economizer eco-circulation valve SW1A to maintain the circulation in boiler. Close the vents to different zones after checking the water start to come out in pressure. Okay. Some options are not simulated. Okay, which are already in the background. You can just it is the procedure for the plant peoples. Now I am going to. Now it is increasing again. I have to open this circulation line. So I'm going to open. So once I have given open, the already tank is the floor is coming due to the pressure difference, high pressure difference. The tank actually filled up. So I have to close it again, and I have to reduce the pressure there. Like there is a lot of procedure is there. Okay, we have to see what one condition is there happens. What's the problem? We have to check it, and we have to again redo it for again. So now the pressure is dropped. Sometimes I'm going to give it 25%. Or I'm going to reach it 30. As you can see now the boiler feed pump is tripped here. When switch it off, we didn't touch it. It happens because of the level we have is reduced from below the particular set point. So since because of that, automatically the level is the boiler pump is tripped. We have to since it is now touching near to the housing, let us wait for some time because already boiler drum is open there. I'm going back there. I'm going to open this line to further more, like let's say 50% to reduce the drum value to 20. Now I'm opening the recirculation valve again to check how the whether it is increasing again or I have to wait for some time again. So now it is rising, so I have to close it again and I have to wait for some time to run up the valve to reduce the flow. It will happen once you can understand once it is going to process. It's a large plan. It will take some time to really it will take some nearly 1.5 hours to get to the steady state model. Let us see the next procedure for to what we have to do in the meantime. We have to start the AHAC motor in the industrial draft fan and check the furnace pressure in normal range. ID fan should be switched on and PC05 valve should be open to 5%, and we have to maintain the furnace pressure at negative value. So let us do that in the meantime. Let it reduce that. In the meantime, we can reduce. I'm going to switch on the AC motor for MS07, which is here MS07. I'm switching it on. I'm going to switch on the ID fan, which is the next one, MS06. So I'm going to switch on the MS06. And the PC05 to open it to 5%. So I'm selecting the PC05, which is near here. I'm selecting that and I'm opening to 5%. So MV I am increasing to 5%. Once I increase that, you can see the pressure drop here. It started to reduce and it will goes to the negative value. You have to maintain the value at the negative range only. Okay, so let us maintain that one. and let us see whether the drum has been filled up or not. I'm going back to the condensate system. The tank level is above 1000. Now I'm going to switch it on the pump again. Now the flow is generated. I am closing the valve for some time to reduce the flow there, because I already the boiler drum, the flow is high, so I'm reducing the flow to. Now it is again filled up. Since the pressure started to build up, the flow is increasing. You can see it in here. So I have to close the level control valve and pressure control valve to again to 20% again, and increase this to 70%, let's say. Since the pressure is building now, the level will start to reduce. Meantime. Oh, sorry, the level is actually reduced to zero. The level is actually reduced to zero. I have to build up. I'm increasing the PC02 value to 25% to build up the pressure and the flow, and increasing the valve position to, let's say, 40%. So like that, we have to change the according to the procedure. We have to change some things, and it will take some time to get to the model first. So let me show some small models to you for that next purpose. Okay, so everyone gets the point, no, how to start the procedure. You have to read the procedures and you have to do it accordingly. Since if you understand the process well, you can get try it for sometimes you can get the understand process well. So I'm moving on to the, let me move on to the next model for your detail next to show the next model. Open. I'm going here to select the, let us say, combined power cycle power plant model. I'm clicking on the operator section and CS3000. Same procedure, F5. Now you can see in the combined power plant cycle, it is both the gas turbine and the thermal power plant will be, you can see that. So let me see the overview. You can see two generators here, one from the gas turbine. Uh, uh,
Sir, Haja sir,
yes,
now
sir.
you just now it's already 4:30. Their timing is almost over now. So what we you can do? Recording is going on already. Whatever we have presented, recording is already there. So they can do that. If everyone missed something, they can. I'll upload this video to YouTube. They can go through that. So in the
Okay.
meantime, you just try to explain the whatever the main power plant model which are left, so they will get the idea where are the what are the things and what are the models. So basically I think combine, after you just explain them, not don't show each and every step by step, or you have to give just now the nuclear as well as the hydro, and this combine
Okay, okay.
5 minutes on each and every model only.
Okay, 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 sir. Just I will give the explanation on that. Okay. So let me just speed up that. So I'll just show you the overview and you can see from there. Okay. You can see that it's like air system compared to the gas turbine and combustion chamber similar to the gas turbine. See three more pages, and from here you can see the thermal power plant model section same here. And here, this is the tripologic section which I have tried to show in that power plant thermal power plant matter. These are the conditions which will be present. If this particular left side condition is satisfied, the right side will also get stripped. Like let's say the tank level is less than first option is fuel tank oil storage tank level is Less than 300 means the trip condition will be enabled, and you cannot switch on the fuel oil pump. So like that, there are some trip conditions present in some models. You can see it in the manual also. There are some of some models you can see it in the operating station itself. You have to check it. There is a soft keys in the bottom of the operating station. You can check, select that, and you can see the trip conditions, and you can move to the pages according to same accordingly. Okay, so let me move on to the next model. Open, and these are pop and I'm selecting 5016. I'm opening the model. F5, same overview is there. So the planned overview, diesel storage to the engine, and the lube oil to the engine, and fresh air to the engine. And from there, the engine is connected to the synchronizer, where the power is generated to the through here, and the cooling oil will be circulated to the cooling tower. It has separate sections there. I just show the pages accordingly. This is the fuel oil and the fresh air supply section. This is the actual diesel engine, and the alternator section is there, and the lube oil section is near to the cooler section below. And this is the cooling tower section. The coolant oil is supplied, and reflects back to the cooling tower and reused in the plant. So these are the, yeah. Every plant has the design state and cold start condition, and every you can use the manual given in the given, and you can start up the model. It will take some time, but you can learn a lot from there. So let me show the next one, nuclear power plant. The model number is PS5017 for the nuclear power plant. I'll just open the operator session. This one is somewhat smaller compared to the previous models. This is the first one is a condensate and IET system. The similar to the temper power plant, from the condenser only the oil is feed water is supplied to the drum through the IET section. And you can see the next one, the nuclear reactor is in the red color section. Here we have to give the position of the fuel rod. So based on the position, the power generator, amount of heat generated varies. So we have to give the position correctly, and then we can be using that. The steam generator will produce the steam, which is used in the turbine, and the generator utilize the turbine to produce the power. And how much power is generated, you can see it in the bottom dialog boxes there. So just let me move on to the next one. It will be hydroelectric power plant. Okay, PS5018. So I am selecting the operator session now again. And as you can see, this is the overview of the power plant. The reservoir, such tank, and the turbine to the generator. The lube oil to the generator, and the turbines, and the cooling water to the generators are being connected. This is an overview. You can see there are actually for 6 turbines and 6 generators will be there. So reservoir and power generation 1, and turbine power generation 2. So 2 sections will be there. So nearly 6 power sections will be there. It is an actually
Yeah, sir, you can explain something here. You can do a little bit simulation in this area, so they'll get some idea. Yeah.
Okay, so let me just give a simulation in this one. HC0 FC101. The whole power plant, hydro power plant is based on the how much flow of the water which is going to the turbine. So let me reduce the power plant value, and you have to know the power generation. So total power is 150 megawatt is actually generated, and this actual particular generator which is generating 25 megawatt, which you can see it here, PI03 and FC01 other. So I'm going to change the flow here directly. by changing the SP. And I'm going to now you can see the power generation changes in the PI03. So let me change the set value to, let's say, reduce to, since it is 74,000, let me give like 50,000. Sorry, the model is in the hold condition. Let me just let me run the model and come here, auto mode, and 50,000 is there. And I'm clicking enter. Now the model reduced flow. Accordingly, you can see the power generation also dropped accordingly. From the 25 megawatt power plant, now suddenly it will drop, but once after some time it will take a steady, come to steady value. You can also change see the changes in the total power generator. Usually it will be in 150 megawatt, but now it is reduced to 160. So likewise, we can change the simulation also. The main power, you can learn a lot in the startup procedure. Try to select the small model first and try to start do the cold start in the, just like in the pulverizer system. It will take very less time to do it. Okay, and similarly you can change this, see the changes in there. So combined of that, and you can change the loop while to each and every turbine here from here, and the cooling water supply to the generators are being connected here. You can monitor the line CWAS to generator 1, CWAS to generator 4. The number will be depicted, so you can see that out and you can change accordingly. And this is the whole total power generation, the each and every turbine. Okay. So let me show you another small model for understanding purposes. So here you can, as you can see, there are selected in all models. So usually the power plant operation, if you selected this, only 5 models will be there. This will cover the whole power plant operations of the whole power plant operation. If you want to go in depth of a particular in depth to knowledge, you can select the power plant boiler operations shoot, which will show the particular operation related to the boiler sections only. Pulverizer, oil firing, flue gas, superheater, reheater, boiler drum, and water treatment plant related to the boiler section. When you are selecting, if you want to see the condensed turbine section, means you can select here. Let me select one model here and I will show you one thing. Let us say circulating cooling water system, let us say. I am selecting that. I am clicking OK. The model is I'm opening the, let me run the model first, and I'm selecting the operator station. I am selecting F5. Now you can see it is a simple model. Now how the water system is circulated to the condenser to the cooling tower. The actual lineup is here, and you can see the manual here with a small description here. It will comprises of only 5 pages only, and you can see the whole startup procedures also. For some models, there will not be any cold start because it will be a small model. For only design state is there, you can actually change some values and you can see the simulations. Now let me just, for example, I'm changing the condenser temperature controller to this one 40 degrees Celsius. So let me just increase it to 47. Accordingly, the values will be changed. The flow will be reduced. The cooling water from which coming to the condenser, the flow will be reduced. You can see it here accordingly. So likewise, you can get the in-depth knowledge of each and every operation using this particular suite. Okay, and let me show for the next electrical operations. So these are generally for the power generation systems. 6.5 6.5 kilowatt. This comprises of the generator systems only, the exciter and transformers, similar models. Let me just show you one. 5054 415 kilo 415 volt system. I'm opening that 5054 and so as you can see, directly we are seeing the executive restrictions only, which you can use it for power generation purpose. 450 volt system. So this one does not comprises any other things like boiler sections are there. Only the generator, how the generation is occurring. That particular section is will be displayed here. Okay. So similar, we can open the balance of plant BOP is nothing but the handling plan, like whole handling section, how the whole is handling a particular power plant. Yeah, you can study for that also. I'm clicking 5061 whole handling section. Yes, I'm going to open the operator section. As you can see now, it is a whole uh, coal handling section is there. So here the wagon tripper, where it is coming vibrating feeder is there, where it is from there it is conveyed to the bent conveyor to the particular crushers, primary and secondary crushers, and how it is going to the coal yard, and from the coal yard how it's going to the next section to the bunker. Separate storage bunkers will be there. So how it is stored here, you can see the whole section is there. Sorry. Likewise, we can use the whole model center. If you are using any startup procedures in any popular model, try to use the snapshot option, because it will take time to fill some tanks, and it will whole day to get the steady state of the model. You can use the control, you change the control to auto mode to for your EM for NM, utilizing less amount of time, and let the controller take the steps for you. And use the snapshot option to save the particular condition file, so you can continue with the next day, and you can complete the whole model within 2 days. Like that, you can take the timeline and you can utilize that also. In students' point of view, you can utilize the particular PV logging and PV trend options to take the values accordingly. They can change any factor. They have to give a particular valid explanation on why they are change the particular value and how it is actually affecting the process. They have to understand that. Then using that also, then they can log the particular values and use it for the lab purposes. The procedures will be can be generated based on it will be varied accordingly to your campuses. So the particular staff can be selected the models, and they can select what are the readings should be taken. They can prepare a manual based on that, and utilize software to learn, give the students much more understanding on the process. So that much about the overview of the whole problem models which I have shown you. Anybody having any queries related to you how to use it, or any doubts, you can ask now.
Yes, if anyone has a query, doubt, questions, anything he wants to say, anyone wants to say something which was till now conducted, or something has to be repeated, please ask the questions. So then, if it's clear, then we can conclude the session. As well as I'll upload this session to the YouTube, and I'll share the link with the HOD sir and all of you. So you can repeatedly see the video and use that by your own also. So any questions, please go ahead.
No question. Okay. Thank you.
Everything is okay? Fine?
Okay.
Yeah. So I'll upload the sessions. Any doubt, any questions, you can directly mail us. Or in future, again, once I think academic starts in the next semester or somewhere, again, you want a session, we will be there for you. Okay, sir?
Okay.
Yes. So we'll conclude the session. Thank you very much, Aja sir, and
Thank you very much, sir.
everyone like Veer sir, Vikas sir, Vipul sir, Prayas sir, Vinay sir, Sumit Kumar, as well as Suresh Kumar. All of you, thank you for being with us, and special thank to Prayas sir for coordinating this at very well in very much time, in a short time, as well as a uh, very superb way. Thank you everyone. So I think
Thank you, team. Thank you.
Thank you.